Hey everyone, and welcome back to another video. Following our last lab, we have covered Layer 2 LACP. We have briefly discussed what and why we would need Layer 2 LACP, and also we discussed how it worked. I have provided the URL for that video in the description below for those who are interested. Today, we are going to walk you through the process of configuring and verifying Layer 3 LACP. We will start with a quick comparison between Layer 2 and Layer 3 LACP. Next, we will discuss why we might need to use Layer 3 LACP. And then after that, we will outline the lab objectives, review the lab topology and the lab tables, and then walk through the lab tasks. Finally, we will guide you through the solution step by step. By the end of this session, you will have a thorough understanding of Layer 3 LACP and how to use it effectively in your network. And also, not to mention that this lab will help those that are looking to obtain their CCNA qualification. So, first things first, what is the difference between Layer 2 and Layer 3 LACP? The differences between Layer 2 and Layer 3 LACP lie in how and where they operate within the network. So let's say, for example, that the scope of operation is different between both of them. For instance, Layer 2 LACP operates at the data link layer of the OSI model, as it deals with MAC addresses and is used primarily within a local network, such as between switches or between a switch and a server. Whereas the Layer 3 LACP operates at the network layer or Layer 3, and it deals with the IP addresses and is used for routing traffic between different networks. So, regarding the use case, we will see that Layer 2 LACP is typically used within the same local area network, whereas Layer 3 LACP is typically used for connections between Layer 3 switches or routers. In terms of addressing, Layer 2 LACP uses MAC addresses to manage traffic, so frames are forwarded based on the MAC address table, whereas Layer 3 LACP uses IP addresses to manage traffic, and routing decisions are based on IP address table. Regarding the configuration, Layer 2 uses switch ports and Layer 3 uses routed ports. Finally, let's talk about load balancing methods. Layer 3 can use all load balancing methods that Layer 2 uses, but Layer 2 can't use all possible methods that Layer 3 uses. This is purely because Layer 3 LACP can use IP and port number as the source and destination when it comes to load balancing mechanism. Okay, so let's move into the next section where we're going to discuss why we would use Layer 3 LACP. So one of the use cases that you might need to use Layer 3 LACP is scalability. Let's say, for example, that you want to scale your network bandwidth. You can use L3 LACP to upgrade to a higher bandwidth without the need to upgrade your hardware. We also can use Layer 3 LACP for reliability and redundancy. Let's say that we have multiple links within the Ether channel and one of the links went down. This means that the network is still operational and the network hasn't been disturbed. However, this obviously if the current usage is less than 50% of the total bandwidth. Finally, we can use L3 LACP to balance traffic across all links, making it better use of available resources. So as you can see from the table I included in the lab and the document, in order for Layer 3 Ether channel to work or form, at least one of the switches must be set in active mode. If, however, both switches were configured in passive mode, the Ether channel will not form. So, okay, let's move to the lab objectives. The objective of this lab is to provide hands-on experience in configuring and verifying Layer 3 Ether channel using the LACP protocol on Cisco Layer 3 switches. By the end of this lab, you will be able to understand the concept and benefit of EtherChannel and LACP protocol. You will be able to configure layer 3 EtherChannel using LACP protocol in both active and passive mode. You will be able to verify the operational status and configuration of the EtherChannel, and you will be able to troubleshoot common issues related to EtherChannel and LACP protocol. We will also perform a failover test to make sure that we will have network operation continuity. So regarding the lab tables, the first table we are going to tackle is the switch VLAN table. As you can see on the screen, the table presents details regarding devices, interface configuration, and associated VLANs. So the device name, this column lists the name of the network devices that you see in the lab topology. The interface ID, this column displays the unique identifiers of the interfaces on the respective devices. And here the interface mode column, and here it indicates the operational mode of each interface. And then finally, we can see the VLAN ID. This column lists the VLAN IDs assigned to the respective interfaces, indicating the VLAN membership of each interface. The second table we are going to tackle next is the IPv4 address table. And this table again presents detail regarding devices, interface configuration, and IPv4 address information. So similarly with the switch VLAN table, we can see the device name and interface ID. This is quite similar to the table above as we explained. We can see the IPv4 address column, and this column shows what each interface will utilize which IPv4 address. And in this column, we can see that the physical interfaces will not have an IPv4 address. However, they will be part or member of EtherChannel Group 10, and each port channel will have a unique IPv4 address. For example, you can see that the Gig Ethernet 1/1/1 will be member of port EtherChannel 10, and the same applies for Gig Ethernet 1/1/2, and both of them will not have an IPv4 address. However, both of them will be routed ports, and both of them will be part of the port channel 10, as you can see on the screen. So port channel 10 we will assign 10.10.10.1, and the subnet mask is going to be 255.255.255.252. This is /30. And the same applies for switch 2 as well. Now let's move into the SVI table. Again, this table is similar to the table above, but in this case, we will be using a logical interface such as SVIs on each switch to assign an IPv4 address for management purposes. And then finally, the end host IPv4 address table. And this is just for your information. In this lab, we have configured each end host prior to the lab with the information you see on this table. For example, PC1 will be configured with 192.168.10.100. The subnet mask is /24, is going to be part of VLAN 10. And this is the default gateway, which is the SVI 10 on switch 1, for example. So with regards to the lab topology, as you can see on the screen, we have 4 different departments across our network lab. We can see the IT department that resides in VLAN 10, the HR department that resides in VLAN 20, the sales department that resides in VLAN 30, and finally the research department that resides in VLAN 40. PC1 and PC2 are connected to switch 1, and similarly on the other side, PC3 and PC4 are connected to switch 2. Switch 1 and switch 2 are interconnected via Gig Ethernet 1/1/1 as well as Gig Ethernet 1/1/2. And these links will be configured as part of port channel 10 using layer 3 LACP protocol. The main goal by the end of this lab is to provide connectivity between different departments and provide redundancy between switch 1 and switch 2 should one of the links fail. Okay, so next let's move into the lab task. And the first task is we are going to create VLAN and SVI configuration on switch 1 and switch 2. So for example, on switch 1, we are going to create VLAN 10 and 20. We're going to name each VLAN, and then we're going to create the SVI for each switch. And then after that, we will do or perform some in-flight checks and verify our configuration. We then move into access port configuration where we're gonna configure, for instance, gig Ethernet 1/0/1 and 1/0/2, which are pointing to the end hosts. We're gonna configure each interface with the appropriate VLAN, with the appropriate description, and the appropriate access mode as well. Once we've done that, we will verify our configuration as usual. We then move into the end host configuration. And as I mentioned earlier, this step is already been done. However, if you are going to build this lab by yourself, then you would need to tackle that step as well. Then we're going to move into step number 4, where we are going to check if IP routing is enabled. If is not enabled, then we will enable it. And then we are going to answer why we would need to enable IP routing, what is the purpose behind it, and why do we need this essential step in order for us to proceed to the next stage. Next, we move into step 5, where we are going to perform some switch interlinks configuration. This is where we are going to convert the switch port to a routed port. So we're going to jump into gig Ethernet 1/1/1 and 1/1/2 and configure them as routed port. We will explain the difference between routed ports and switched ports, and we will verify our configuration accordingly. We then move to step number 6, where we are going to configure layer 3 Ether channel by using LACP protocol on both interfaces, gig Ethernet 1/1/1 and /2 on both switches as well. Next, we are going to move to step 7, where we are going to assign an IPv4 address to each port channel that is being created on each switch. And also we are going to verify our configuration once we have configured this. And then we will initiate a ping between switch 1 and switch 2 using the command ping 10.10.10.2 from switch 1 CLI. And then we will check if the ping is successful. If not, then we will have to do further troubleshooting and investigate why the ping is not reachable, etc., etc. Then we're going to move to step number 8, where we are going to configure a static route between switch 1 and switch 2, and also vice versa. And the reason being is because we want to be able to provide connectivity across all departments. And as I explained earlier, we have 4 different departments. Each department resides in different VLANs or a different network, and we want to make sure that each department is able to reach any other department. And then after this, we will perform some in-flight checks. And then after this, we're going to move into step 9, where we are going to perform some connectivity tests. We're going to initiate a ping from PC1 to PC2 to PC3 and PC4. And also we're going to do the same for PC2. So we're going to initiate a ping from PC2 to PC1 and PC3 and PC4. After this, we're going to move to step number 10, where we are going to mimic a link failure to check connectivity between each department. So we are going to jump into PC1 and we will initiate a ping or a continuous ping from PC1 to PC4. And then we will quickly jump into switch 1 CLI and we will quickly shut the one of the interfaces that are part of members of the EtherChannel group 10. And then we will observe the connectivity if it has been disturbed or if there are any connectivity issues, whatnot. We will find out what is going on during that experiment. And then after that, we will roll back the interface changes and we will enable the interface once more. And then after this, we will move into step 11, where we are going to tackle the EtherChannel load balancing configuration. We will find out what is the current and default load balancing mechanism. And then we're going to change that load balancing from whatever the default value is to the source and destination IP address. And then after that, we will do some in-flight checks. And then finally, we would do a final test or final ping test from PC3 to PC1 and make sure that the ping is successful. If the ping is successful, we can go ahead, save our configuration, and that will be the end of the lab. If, however, the ping is not successful, we can then go through these steps to troubleshoot the issue, isolate the problem, and try to fix it here and there. So this is the moment where I ask you to pause the video and give this a go yourself to test your knowledge and skills. So I added the lab document in the video description so that you can download it and practice at your own pace. I have also included a couple of packet tracer labs for you to download. You will find a pre and a post version of the lab. And the pre-lab is for those who want the lab ready to go and tackle all tasks, and the post-lab is for those who want the full lab solution. So enough of that, and let's dive into the lab solution. Okay, so I'm going to tackle the first task, and the first task is to create VLAN and SVI configuration on switch 1 and switch 2. So I'm going to jump into switch 1 first. I'm going to go to the CLI. I'll do the same thing on CLI2 as well. I'll go to user privilege mode, and then from there I'll go to the global config mode, and then I will create the VLAN quickly, VLAN 10, and I'm going to name that VLAN to IT department. And then create VLAN 20 and call it the HR department. Next, I will create the SVI VLAN 10 first. So I'll say interface VLAN 10. I will assign the IPv4 address to it. So it's going to be 192 or IP address 192.168.10.10/24. Let's do the same thing with the SVI 20. And the IPv4 address will be 192.168.20.10/24. So let's quickly do the same thing on switch 2. Start with VLAN 30, and I'm going to name that sales department. And then change the VLAN 30 to VLAN 40, and then configure the VLAN description. Next, let's tackle the SVI. So we want to create two SVIs, SVI 30 and SVI 40. So I'm going to say interface VLAN 30. And then I'm going to say IP address 192.168.30.10/24. And now SVI 40 is also configured. Next, let's perform some in-flight checks. So I'm going to start with switch 1. So I'm going to say show IP interface brief, and let's just include the LAN. And here you can see that we've got two SVIs, SVI 10 and SVI 20, with the appropriate IPv4 address. Right now, as you can see, is in the up-down state, and the reason being is because no VLANs has been assigned to any of the physical interfaces, but this step will be tackled soon. Next, let's issue the show VLAN brief. And here we can see that we've created two VLANs, VLAN 10, which is the IT department, VLAN 20, which is the HR department. As mentioned earlier, no physical interface has been assigned to any of these two VLANs. So let's quickly do the same thing on switch 2. And here we can see VLAN 30 and VLAN 40 with the appropriate IPv4 address. And here is also, we have two different VLANs that have been created, 30 and 40, 30 for sales department and 40 for the research department. If you want to perform some additional in-flight checks, what you can do, you can say show interface VLAN 30. And here you can see that the VLAN is in the up-down state. You can see the MAC address of that logical interface. The network address or the interface address is the 192.168.30.10/24. And you can see the rest of the interface or the physical interface attributes. So if you want to also perform another in-flight checks, you can say show running and then pipe section VLAN 30. And here you will be able to see the actual or the current configuration for VLAN 30 from the running config. Next, let's move into step 2, where we are going to do some configuration across our access ports on switch 1 and switch 2. So I'm going to go back to switch 1. And then from there, I'll go back to global config. And then I'll start to tackle the first interface, which is interface gig Ethernet 1/0/1. And first things first, I'm going to start with the description. So I'm going to say link to PC1. Then I will enforce the switch port mode to access. And then I will assign the access VLAN to 10. Now you can see that SVI 10 is gone up. Next, let's tackle interface gig Ethernet 1/0/2. Set the description and then enforce the mode operation to access. And then finally, let's assign the interface to the respective VLAN. Now let's perform some in-flight checks quickly. So I'm going to say show IP interface brief, and I'm going to include only the LAN interfaces. And you can see that VLAN 10 and VLAN 20, or SVI 10 and SVI 20, are in the up state, which is good. Next, if I say show VLAN brief, you can see that these two interfaces are now associated with the appropriate interface with the appropriate department. Next, let's move into switch 2 and do the same thing. So I'm going to go back to switch 2, and then I'll go back to global config. And from there, I would say interface gig Ethernet 1/0/1, set the description. I'm going to say link to PC3. Next, switch port mode access, switch port access VLAN 30. Again, the SVI interface went from the down state to the up state. Let's do the same thing for the second interface, which is pointing or connected to the PC4. Set the description and then set the mode access. And then finally, let's set the VLAN. Let's perform some in-flight checks. So I'll show VLAN brief, and you can see these two interfaces are part of the respective department. And finally, let's say show IP interface brief. As you can see from the output, we can see that the both SVIs are now in the up state. We can see the physical interfaces that interconnects both the switches are also in the up state. And finally, the interfaces that then connects to the end hosts are also in the up state. Next, let's move into step 3. And as mentioned earlier, that step 3 is already been done. But for the sake of it, I'm going to go back to the topology and walk you through a couple of computers to show you that each computer has the appropriate IPv4 address. So we are on our PC1, and right now this is the IPv4 address that is being configured on PC1. So the IPv4 configuration is 192.168.10.100. 24 in terms of the subnet mask, and the default gateway is 192.168.10.10. So this PC is good to go. Let's examine, let's say, PC4, for example. If I go back to desktop and then go to the IP configuration, and under the static section, you can see that this is the IPv4 configurations or settings that is being pre-configured prior to the lab. So next, we're going to move into step 4, where we are going to check if IP routing is enabled by default or not. So I'm going to go back to switch 1. And from here, what I will do, I will say show IP route. And you can see that this is not being enabled at the moment. And as you can see from the output, there is no routing table. Therefore, the switch is not operating in layer 3 as we speak. In order for us to do that, it's quite simple. We can go to global config, and then from here we can issue the IP routing command. Let's end this. If I perform some in-flight checks, let's start with the running config. So if I say show run pipe include, and let's say routing, you will see that there is the command that is being inserted in the running config. And also if I say show IP route, you will see this is the routing table that we are after, and that indicates that the switch is also operating in layer 3, as you can see on the screen. Let's do the same thing on switch 2. So I'll go back to, actually before I go to global config, let's just make sure that IP routing is not being enabled, and I'm going to start with revealing the current config, and I'm going to say only include routing. And you can see that we are not having any command that indicates that routing is being enabled on the switch. And also, if you want to do additional verification, we can say show IP route, and you can see that this has not been set. And if in order for us to do that, we'll go back to global config, and we're going to say IP routing. Let's end this and then perform some in-flight checks. You can see this has been taken in the running config. And then if I say show IP route, we can see that we have two networks, that each network is associated with different VLANs. So on a layer 3 switch, enabling IP routing is essential for multiple reasons. The first reason is obviously enter VLAN routing, allowing different departments to be able to communicate with each other, and also being able to route between different networks. And also we can use advanced routing capabilities, like for example, using OSPF, EIGRP, or BGP. Those routing protocols will be discussed in the near future. And also enabling IP routing can help with redundancy and load balancing and network efficiency. So basically enabling IP routing on a layer 3 switch transforms it into a versatile network device capable of performing both switching and routing functions, thereby improving the overall efficiency and capability of the network. Next, let's move into step 5, where we are going to do some configuration across both switches related to the interlinks configuration. So we are going to configure gig Ethernet 1/1/1 as well as gig Ethernet 1/1/2 to be routed ports. First of all, before we do that, let's examine what is the current status of each interface and how do we tell the difference between a switched port versus a routed port. We will explain that just right now. So let me go back to switch 1. And from here, what I will do first, I will say show interface gig Ethernet 1/1/1, and then I will also include the word switch port. And here you can see that switch port is being enabled. That means that this interface right now, as we speak, is operating in layer 2. Let's do the same thing for interface gig Ethernet 1/1/2. And you can see that switch port is being enabled as well. Okay, so let's change that to routed port. So I'm going to go back to global config, And from here, I would say interface range, and I would say gig Ethernet 1/1/1/1-2 to include both interfaces. So we can configure both interfaces simultaneously or at the same time. I will hit enter. And from here, I will say no switch port. That's it. As simple as this. So if I hit end, and then let's do some in-flight checks. So I'm going to say show interface gig Ethernet 1/1/2 or /1, and then include the word switch port. Let's see the output. Now the output is saying switch port is being disabled, and therefore all the different attributes that comes under layer 2 is being disabled, and you will not be able to see it or not be able to use it. So let's do the same thing on switch 2. So before we actually tackle this, let's just say show interface gig Ethernet 1/1/1, and then we will include the word switch port. And you can see that the switch port at the moment is being enabled, which means that this interface is operating in layer 2. Do the same thing on gig Ethernet 1/1/2. And both of these interfaces are operating in layer 2. Let's change that quickly. Now we're going to say global, we're going to say configure terminal interface range gig Ethernet 1/1/1-2. And then we're going to say no switch port. Let's do some in-flight checks. And right now you can see that gig Ethernet 1/1/1 is being disabled, which means is operating in layer 3. Let's just double check that on gig Ethernet 1/1/2, and we get similar output. So what is the difference between routed port and switch port? So routed ports is a layer 3 ports. In terms of function, routed ports are used to route traffic between different IP subnets and VLANs, and they operate at layer 3 of the OSI model, which is the network layer. In terms of the configuration, these ports are configured with an IPv4 address and subnet mask, similar to how you would configure a port on a router. Also, they are capable of IPv6 address, not just IPv4. In terms of the use case, they are typically used for inter-VLAN routing, connecting different networks, or connecting to a WAN, which is the wide area network. And regarding the behavior, routed ports do not participate in the layer 2 switching process, such as MAC address learning and forwarding. Instead, they make forwarding decision based on the destination IP address. On the other hand, we can see the switch ports. These are layer 2 ports. In terms of the function, switched ports are used to connect end devices such as PCs, printers, servers, etc., or other switches. They operate at layer 2 of the OSI model, which is the data link layer. In terms of the configuration, these ports are configured to operate in access mode or trunk mode. Access ports belong to a single VLAN, while trunk ports can carry traffic for multiple VLANs. Regarding the use case, they are typically used within a VLAN to connect end devices and within the same broadcast domain. Regarding the behavior, we know that switched ports participate in the MAC address learning process and make forwarding decisions based on the destination MAC address. They also handle VLAN tagging and stripping in the case of trunk ports. Okay, so with that being said, let's move into step 6. And step 6, we are going to actually create the layer 3 Ether channel by using LACP protocol on ports gig Ethernet 1/1/1 and /2. So I'm going to start with switch 1 as usual. So I'll go back to switch 1. And from there, I'll go to global config once more, and then I'll use the interface range command. And I'll say 1/1/1/1-2. And then here I'm going to say channel. If I question mark that, you can see channel group as one of the options. And then from here, we can use any channel ID from 1 all the way to 48, but according to the playbook, we would need to use EtherChannel 10 or port channel or channel group 10. And then if we question mark that to reveal the content sensitive help, the only command that is available to us is the setting the mode. And as we discussed earlier, that one of the sides must use the active mode. And then if you question mark that, we can see that there are multiple protocols or multiple options. So the active and the passive for enabling LACP protocol, and the auto desirable is basically for the port aggregation protocol. So I'm going to use the active and I'm going to hit enter. And then let's do the same thing on the other side. So I'll go back to global config, and from here I would say interface range gig ethernet 1/1/1-2, and I would say channel dash group, and I'll set the number 10 for the group ID, and I'm going to say mode, and then here I can say passive, to be honest, and it's still going to work, but for the sake of it I'll just stick with active, and I will hit enter. And now let's perform some in-flight checks. So I'm going to go back to switch 1. I'll then issue the show IP interface brief. And here we can see a new logical interface has been created, and that logical interface is port channel 10. Right now, there is no IPv4 address that's been assigned, and you can see that the current status is in the up state. We can also issue another command, which is the show interface port channel 10. And you can see that this is the logical interface in the up state. You can see the hardware is EtherChannel. This is the MAC address. You can also see the current bandwidth for this interface in kilobits here in this line, and also in megabits per second in this line. Finally, we can issue the show running and then pipe section 1/1/1, and let's just include the $sign. And you can see that this interface is operating in layer 3 because we issued the no switch port. Right now it doesn't have an IPv4 address because it's participating in channel group 10, and you can see the rest of the configuration as well. Another command that you can use is the show interface port channel 10, and then you issue the word status. Here it will tell you that this port channel doesn't have a name at the moment because we haven't set the description. You can see that the current state is connected, and right now, as we speak, is rooted, which means is operating in layer 3. And in terms of duplex, speed type is set to auto because it inherits these attributes from the physical configurations or from the physical attributes. Next, let's issue the show EtherChannel summary command. And in here, we can see this is obviously the flags section where it tells you the definition of each acronym name. So for instance, D means down, P means in port channel, I means standalone, S means suspended, R means layer 3, S means layer 2, so on and so forth. So what we are really interested in is this line here. So we can see the current group that we've configured is group 10. This is the port channel Ether channel 10. Right now it's saying is RU, which means R for layer 3 or rooted ports, and the U, which means is in use, as you can see from the screen here. The current protocol that we are using is the LACP, and the ports that are part of that group are gig Ethernet 1/1/1, gig Ethernet 1/1/2. Both of them are in port channel. Okay, so with that being said, let's move into step number 7, where we are going to assign an IPv4 address to the created port channel. So I will go to global config, and then from there I'm going to say interface port channel 10, and let's set a description. I'm going to say description link, or link to switch 2. And then I'm going to set the IPv4 address. So I'm going to say IP address 10.10.10.1 with the subnet mask 255.255.255.252. Let's just end that, and let's just do some in-flight checks. So I'm going to say show IP interface brief. We're going to say include channel. And you can see right now, we can see an IPv4 address that's been assigned to this port channel. If we say show running pipe section channel $10, you can see this is the current configuration under this logical interface. And then finally, if I issue the show EtherChannel summary, we can see similar output. Next, let's issue show interface port channel 10 status. And here we can see that we have added a description under the name of the interface, and we get similar attributes to what we have seen before. Let's jump into switch 2 and do the same thing. Let's set the description first. I'm going to say link to switch 1. And then we're going to set the IPv4 address, which is going to be 10.10.10.2, 255.255.255.252, which is /30. Then we're going to hit end. And then from here, let's perform some in-flight checks. So I'm going to say show IP interface brief. And we're only going to include channel. And you can see this is the current IPv4 address for this logical interface. And let's do the same thing on the reveal the current configuration. So we're going to say section channel $. So I meant to actually include the 10. And you can see this is the current configuration for this port channel. And next, let's initiate a ping from switch 1 to switch 2. So I'm going to go back to switch 1. And I will say ping 10.10.10.2. And let's see if the ping will work. And yes, the ping works. Let's repeat again. We've lost the first packet, or the first ICMP message due to ARP. And the second time we get 100% success. Next, let's move into step 8, where we would need to configure a static route between switch 1 and switch 2. So we're going to start with switch 1. So again, we're going to go back to global config. And then in here, we're going to say IP route. We're going to set 0.0.0.0 as the destination IP address and the destination MAC address as well. And then we're going to question mark that, and we would need to set the next hop address. So we need to say 10.10.10.2, and we hit enter. And let's just perform some verification. The first verification that we need to do is show running, and we're going to say include route. You can see this line has been taken. And then if I say show IP route, you can see that the gateway of last resort has been configured. And that means if there is a traffic that need to go to a destination that is not known to the router or to the switch, it will look in the routing table, and then it will forward the traffic into the next hop, which is 10.10.10.2, as you can see on the screen. Let's do the same thing on switch 2. So we're going to go back to global config, and from here we're going to say IP route 0.0.0.0, 0.0.0.0, and then the next hop will be 10.10.10.1. Let's perform some in-flight checks. And finally show IP route. And you can see that this has been taken. And we are good to go. So this step is completed now. Next, let's move into step 9, where we're going to perform some connectivity tests between PC1 and PC2, and so on and so forth. So I'll go back to my topology. I'll go back to my PC1, and then I'll go to the command prompt. And from here, I would say ping 192.168.20.100. And you can see that I'm able to reach the HR department. Let's do the same test, but for the sales department, which we are trying to ping PC3. And the ping is also successful. Let's do the same thing for the research department. And now we have reachability between all departments. Let's perform the second test, which is from PC2 to PC3 and PC4. So I'll go to PC2. I would say ping 192.168.10.100. And you can see that we have reachability across our network. So right now we are going to move to step 10, where we will mimicking a link failure to check connectivity between each department. So I'm going to go back to PC1, and from here I will initiate a continuous ping to PC4. So I'm going to say ping -n, and then I'm going to include 1000, and I'll say 192.168.40.100. And in the meantime, I'll go back to switch 2 or switch 1. And I'll go to the interface configuration level for interface gig Ethernet 1/1/1. And on the left hand side, I will initiate the ping, and you can see that the ping is continuous. And while the ping is running, I'll go quickly on switch 1 and I will shut the interface. And as you can see, we haven't actually lost a single packet from PC1. So I'm going to cancel this. I will unshut the interface to roll back the change, and then I'll go back to global config. And then I'll go back to user privilege mode. Next, let's tackle step 11. So I'll go to switch 1. So step 11 is about exploring EtherChannel load balancing method. So let's find out what is the current EtherChannel load balance mechanism. So you can do that by issuing the show EtherChannel load balance command. And right now you can see that the default is the source MAC address. And according to the playbook requirements, we will need to change the default setting to source and destination IPv4 address. So I'm going to go back to global config. And then from here, I will need to execute this command, port channel, and then we'll say load balance, and then we'll question mark that. And you can see all the different methods that the LACP protocol uses to load balance traffic. And right now we would need to actually hit the source and destination IP address or IPv4 address. And then I'm going to hit enter. And then let's just perform some in-flight checks. So do that. We would issue show EtherChannel load balance, and you can see that the mechanism or the method has changed. Let's do the same thing on switch 2. Go back to global config, and from here I would say port channel load balance and then src-dst-ip. And let's just verify that quickly by saying show EtherChannel load balance. And you can see that this is the current setting here, and that step is complete. Final step is to initiate a ping from PC3 to PC1. So I'm going to go back to my topology. I'll go to PC3, and then I'll go to desktop, command prompt, and from here I would say ping 192.168.10.100. And we have successful ping. So this is the end of the lab, and that's it folks for this video. If you found this video helpful, please don't forget to give it a thumbs up, and if you haven't already, please hit that subscribe button and turn on notifications so you never miss our future tutorials and tech insights. If you have any questions, comments, feel free to drop a comment below. I read all your comments and I'm here to assist you. Remember, consistency and hands-on practice are key to success. So stay curious, stay inspired, and until next time, peace.